Hello, everyone, and thank you again for joining me for this guided project on the Polish car price prediction set from Kaggle. And again, I have the link at the top of this workbook. Send me a message if you need it, and I will pass you along the link. So we're here for part number 4, and we're heading on to the pre-processing section. We're going to start with handling some of our outliers. We identified a lot of outliers, not a lot, but quite a few outliers in our data set in various different columns. So we'll start off with the mileage set, and then we'll go to year, and then vol engine. So we'll start off by printing off the 5-point distribution. We can kind of see here where we're getting some ideas of where our tail is, the outliers are laying. And this is hard to kind of just see when you first look at this, but you notice the +5 and the +6. This is how many times you're multiplying it by 10. And so that really means one extra decimal place, one extra zero in your number. So it's quite a bit larger here just to go from the 25th to the maximum value. Let's just see here. Let's plot that out in a little graphic to kind of see and give us a little bit more detail. So we'll do the same thing. So we'll go plot kind equals hist, and this will give us a nice little breakdown of our plot. You can see here, you can't even really see them because there's only a couple, but you can see here by the fact that our plot goes all the way off to the right, we know that there is some data over here that it's trying to capture, really small and non-consequential, but it still affects the plot. And so we know that their outliers really inconsequential, so we really don't need to move it all the way to that side. So what we can do something called clips. So I have the argument that I use is to keep our workflow consistent and make sure I use the same numbers. So we'll go df mileage. So mileage here, and we'll set that as equal to df and then mileage as well. So do mileage here, and we're going to go df dot clip, and so we're going to clip this down from up here all the way down to 4.5 e to the power of 10, or sorry, 10 to the power of 5 is essentially what this works out. E plus 5 is 4.5 times 10 to the power of 5. And so we're going to go move all of our data right over here, and that'll give us a much better distribution. So if we look at this, we'll clip this, and let's look at our final histogram after. And you can see that's a lot better. It's not quite a normal distribution, but now we don't have these such extreme outliers, and we clipped our data to be right over here. So right at the edge of where there was data, to really not skew our data, to not kind of add a bias where we're moving too many values inside. But this tail is maybe a little bit long still, but it gives us some real sense of the data, and we don't have those outliers that would really affect our model. So what we're going to do is we're going to do year next. So if we just plot out year, let's grab one of these and let's just plot this out. So dot plot, and let's go kind equals hist. So you can see here, we get quite a few errors. One of the things that I like to do with years is because there's usually a non-linear relationship. Price could be directly related to the year, or it could be kind of non-linearly related. And so I want to do something a little bit different here than just the clip and move everything up, because really older car years I think should be left as they are, but we don't want to affect our modeling by having such extreme outliers. So we're going to do something to deal with those, and we're going to do something that's called pd.cut. So we're going to essentially bin our outliers. And what I do first is I do df year, so make a new data frame of the df year dot describe. So if we were to look just at this as we see it right here, print it out, and we see we get this, and we get our index over here on the left hand side, and then we get all these values right here. So what we can do with this, if we go df underscore year, and we take everything, we don't want to take the count, mean, standard deviation, but if we use min to the max value, we can really begin to see the values. So what we want to do is we want to take from the 4th position, so index number 3, 0, 1, 2, 3, and take everything else. So if we run that right here, you can see we get min and the max values. So that's good. And if we just go dot values, we'll return everything. We'll essentially change this into an array of just the, I'm going to spell values correctly, of just the values in this. And so we can use this in our pd.cut as our bin value. So it's going to make bins, 4 bins. So if we had 2 bins, there'd be 2 outside. So we need to have the same thing. If there's 4 bins, we need to have 5 to signify the outer limits of all of the bins. And so here we have 5 values making us 4 bins. So what we'll do is we'll just copy and paste this to make our life easy. So we'll go df year equals to df year dot cut dot, or sorry, let's do pd dot cut. So let's put our data frame in here. So let's put our, what we want to cut inside this. And so we're going to cut this. So we're going to give it the series, we're going to give it the bins, and the bins where we're setting our limits for the bins are these values here. So 5 limits will create 4 bins. To keep things simple, we're just going to go G1, G2, G3, G4 for our years to kind of cut those into 4 categories for our 5 limits to create our 4 bins. So let's run that and let's take a look at this right here. So if we run this value count, so you can see here, we get a breakdown of where all the values are. You see they're relatively even. They're not exactly even, but relatively even. And this will give us a nice category to use in our one-hot encoding later on in the data in our workflow. So here we'll do another one. We're going to look at the volume and of vol underscore engine. So if we take a look at this plot, just so that we have a little bit more detail here, and we'll go dot plot kind equals hist. And if we look at that, you can see here that there's a little bit on the left-hand side and a little bit on the right-hand side. This doesn't look like too much right now because this plot is kind of so skewed to the right, but this actually is quite a decent little tail over here to the left as well that we should deal with. So we'll do the same thing. We'll go df volume is equal to df volume dot clip. And we're going to define 2 arguments this time, unlike we did last time. We just defined the upper limit. We're going to say the upper and the lower limit of clip. So lower is 400, so we're cutting it right about right here. And our upper limit is 360, so right about here. So we're going to move these kind of real extreme outliers all the way to the inside. So if we run this, and then let's take a look at that plot afterwards. And you can see we do get a little bit of bunching up over here. So it's not the best. We would like to see this look a little bit more normal, but we're not adding too much bias in either. So we are adding a little bit of bias, but we're not kind of removing all of those extreme values and just moving it into the distribution. We're still leaving a point to highlight that those are quite a bit larger than the rest of our data set. So next we're going to jump into the handling null value. So if we run this, so df